Okay, we're going to be looking at graphing our linear equations and also looking at that rate of change. And we've looked at rate of change, but it might look a little different here, only because we're saying it's that ratio still of the amount of change in the output. And output's just another way to say our y values over the amount of change of our input, which is just another way to say our x values. So nothing is changing here. It's just also continuing to talk about the change in y over the change in x, which we have been calling our slope. So when I go ahead and look at, let's say, a table, and I'm talking about that input. Well, the input is our first variable in our chart, which is the number of lawns. So the input on this will be the number of lawns, where the output is the amount of money she's earning from mowing the lawns. So that's where we're looking at our output. So we want to look at the change of our y's, our output, over the change in our x, which is our input. And when I say, is it constant or is it variable, to see if it's a constant rate of change or not, we're looking at that change in y over the change of x for every single term in our table, which you can see I already did right here to show you each day and the change in those. So first we're looking at the change from day 1 to day 2. So you can see when I looked at the y's, I took that 45 minus 15 to find that change in y. And then I looked at the change in x by taking that x for day 2, subtracting day 1. And we got that 30 over 2, which was 15. Well, I continue that process all the way down. And you can see every ratio, when I looked at the change from one day to the next, is exactly the same. So that's what we call a constant rate of change. If I had even one that was different, it could no longer be called constant. It would have to be a variable rate of change, which might mean not proportional. Well, definitely means not proportional, but it might not even be linear. So let's go ahead and look at this one. I've got a table that's showing the height of the football after it's actually kicked. So when I'm looking at my input is going to be the time, and my output is going to be the height, my x compared to my y. So when we're going ahead and actually finding the rate of change, we want to see the change in y. So I'm going to look at 18 minus 0. Remember that change in y over the change in x. And when I do that, I should get 18 over 0.5 or 1/2, which gives me 36. So that's a rate of change from the first to the second. Now let's go ahead and continue to see about the next one. I'm going to look at the change this time of my y's from one to the next, so 31 minus 18, over the change in my x's, that 1.5 over that 0.5. And when I go ahead to look at that ratio, I will get 13 over 1. Well, when I reduce it, that is a change of 13. I literally at this point don't even have to go on to know if it's constant or variable. There's already a difference. And when it's a difference, it's called variable. Now, could I go on and actually check to see what the next one is? Of course you can. In fact, when I do it on this one, and then look at the 2 and the 1.5, you can see right here, I'm going to get a negative 5 over 0.5, which gives me a negative 10. Definitely not the same. Now let's go ahead and look at it as in terms of a graph. Well, you know our ordered pairs are all in the terms of x, y, x, y, x, y, x, y. So when I'm asking to find the slope from a graph instead of a table, you are actually looking at those points, the x points and the y points. So let's go ahead and look at, it says the hour 1 to hour 2. Well, when I look at hour 2, the y is 30. For hour 1, the y is 15. So when I go over here to look at the change in y, 30 minus 15 gives me that 15. Where the change in x, here's hour 2, here's hour 1, that's where I'm getting the 2 minus 1, which equals 1. And, of course, when I reduce it, I get that rate of change is 15 miles per hour. Well, now, that's great because they're right next to each other, but what happens if I look at the change between maybe not hour 3 or hour 4 or hour 6? What if I just pick any two random points? So they're saying, let's go ahead and look at two others. Let's look at hour 4 compared to hour 1. Well, let's start with hour 4. The y, again, change in y is 60. Hour 1, it was 15. So let's look at that change. 60 minus 15, which gives me 45. Now let's go ahead and check out the x. The x for hour 4 is 4. Of course, for 1, it's 1. So let's go ahead and put that in. 4 minus 1, which gives me 3. When I reduce it, I still get that 15 miles per hour. So that rate of change is still exactly the same no matter what points I look at. So when it's asking me, is it a proportional relationship? I'm hoping you would say absolutely yes, it is a proportion because there's a constant rate of change. In other words, it's linear. And you can see from the graph, it goes through the origin. Those are the two things that have to happen in order for me to say it is a proportion. Now, find Nathan's unit rate. Well, you should know unit rate means where is it that x is 1? Well, if the x is 1 here, where is it hitting? You can see right there it's hitting at the 15. So that unit rate, not only did we look at the rate of change in our graph by doing the change in y over change of x, just from that graph alone, I can see it's 15 miles per hour. So when I look at the rate of change in the unit rate, I'm hoping you see they are exactly the same. And then I'm looking at these two questions, just reviewing. I already have the answers there. Doesn't matter what interval I use to find the rate of change. Doesn't matter what points. Do I have to go in order? Do I have to go ahead and do one right after the other? Absolutely not. You don't have to, because a proportional relationship, it doesn't matter what points you pick, it will have a constant rate of change. So it doesn't matter if you pick hour 1 to 3, 2 to 4, 1 to 4, they will have the same if it is a proportion. And then conjecture. What do you think that the value of r and the point 1r, do you think it's always the unit rate for any situation? And of course, that's going to be no. Because if it's variable, it is yes if it's a proportion, but if you're not sure it's a proportion, then absolutely not. Because if it is a variable rate of change, then, and it's not proportional, that r, where the 1 is, will not be the unit rate. And we saw that in one of our other lessons, where if you got a flat fee of $8 and then got $2 a bag for the popcorn you sold, compared to if you had to sell the popcorn in order to get it. That is definitely one of those situations where that 1r is going to be the unit rate if it's a proportion. But if it's not a proportional linear relationship, it is not. So make sure that you bring any questions you have, and we will continue to look and work with our slope and graphing of those.